So we'll be discussing a new chapter, work, energy, and power. First of all, let's come to what is this work. Please remember the work which we do and the work in physics has basically a different meaning. Okay. In physics, we define work done. Acha, what we have started, we are starting with work and then we'll go with energy and power and all, right? One by one. So first we have started with work. So in physics we define work done or work is done work is done by force. Okay. So please remember here we are defining in physics we define work done by a force when the force displaces the object in its direction. So for example, suppose if there is this object and let's say there is this object and I'm applying the force in this object due to which this object displaces from here to here. So can you see the displacement of the object is in this direction and the force was also in this direction? Yes or no? Then we'll say work is done by the force. Is this clear, guys? Is this example clear, guys?
Yes, sir.
Suppose. What will happen if there is one more force acting on this? Suppose if this is the case, and let's say friction is acting, okay? So I am applying a force, capital F, and on this there is a friction acting. So can you see the direction of friction is in the opposite direction? And let's say the object has displaced from here to here. So can you see over here direction of F vector and S vector is same, whereas the direction of small f friction and the displacement is opposite. Okay. So basically, what will you say over here? The work is done by the force capital F and work is done. Acha. Then you will say work is done by the force F and this work is positive work. We'll talk about positive and negative work a little bit later. Here also you will say the work is done by this force, but this work is. So we'll talk about positive and negative work sooner or later in this. Is this clear? Please write till here, then we'll start again. Yes, Cyril, why are
Hello,
you late?
sir. Good evening.
Good evening. Why are
But
you late?
10 minutes. The only 10 minutes. Sorry, sir.
Does matter? 10 minutes, 2 minutes. Does that matter?
Sir, sorry.
नहीं सॉरी तो ठीक है वो तो बाद में आएगा बट व्हाट वाज द रीजन यू वर
Sir, only 10 minutes. No, sir. I'm very sorry.
अरे हाँ ना मेरे भाई आई एम टेलिंग यू इट्स ओके बट आई एम आस्किंग यू व्हाट इज द रीजन
Sir, personal works basically.
वर्क
सो जाना, खाना खाना, वो सब.
ठीक है नो प्रॉब्लम चलिए so basically this is your work done by the fourth please remember can you see in this
Sir,
case
what did I miss?
hmm,
So what did I miss?
you basically missed this you basically what is work so basically in physics
Oh,
we
that much
define
only.
work by a force work is done by a force when the force displaces the object in its direction okay and we discussed
Yes,
this
sir.
particular thing can be there is an object you are applying a force F due to which this object is getting displaced from here to here so then you say work is done by the force and this work will be positive work. In the second case we applied friction as well so when we applied
Yes, sir.
friction when we said the work is done by both the forces can you see F is also doing work and small f is also doing work, but the work done by capital F is positive whereas small f is negative. Why it is positive and negative? Because in the direction we define it as positive and in the opposite direction is
Negative.
we'll talk about this positive and negative work later. Okay?
Yes, sir.
Work is simply we'll learn more about this particular point when I'll discuss work energy theorem. So work is simply the additional energy provided by the application of a force by the application of a net external is this clear guys is this clear work is said to be done by a force when that force produces certain displacement in its direction right yes or no guys guys are you writing along with me
Yes,
Yes.
sir.
so it is simply calculated by the product of force and the component of displacement in the direction of force or can you see this and the previous point they are one and the same thing just what did I do I just changed the position of the words right I'll tell you what exactly it means please first when you write down the statement tell me then we'll see exactly what does it mean. Guys, are you done? Is everyone done writing this?
Yes, sir.
Done, sir.
Where is Tanish? Tanish is not still not here.
God knows, sir.
So guys, suppose let me draw an object. Everyone is able to see this object, right? So let's say this object is present over here and I'm applying a force in this direction. Can you see over here, guys? This is the force vector. And let's say the force is acting at an angle theta. There is no friction or anything. Let's say only this force is there. Okay. And due to this force, the object is basically displacing from here. Here. Is this clear, guys? So basically, the object displaced from where to where? From this position A to this position B. Let's say, है ना? At this position, also the same force is acting, F, and this is this theta. What we are discussing is basically work done by a constant force. When this force is constant. So I told you about this particular thing. In this case and the next case, what will you do? Yeah, let me draw the displacement vector as well. So, guys, are you able to see two different vector quantities? There is this force vector and then this displacement vector. Yes or no? Yes or no, guys?
Yes, sir.
So basically, I can see this is your force, and this is your right. Can I say this? Hello. Can I say this, guys? This is your force at an angle with displacement vector theta. Yes or no? Force vector at an angle theta with the displacement vector. Can I say this, guys? Are yes or no? Can I say this or not? This was the condition which was given in the question. Hello, guys. This is the condition which is given in the question. If the force vector, due to this force vector, this object will be displaced by an angle by a displacement s. So now the question is, what is basically the this one? Hello people,
Yes, sir.
क्या अभी तक क्या समझना है? कुछ समझना है? क्या बोला? This is basically the condition which I'm taking. And I have given only one condition over here. There is this object M. Can you see this object M in both the cases? I am applying a force of how much? Yes, guys, I am applying a force of F at an angle theta with the displacement. So can you see in both the cases these vectors will be formed? Yes or no?
Yes, sir.
When these vectors will be formed, now what to do? In the first case, can you see over here? It is simply calculated by the product of force and the component of displacement in the direction of force. So in the first case, basically what will I do? Can you see over here this displacement vector? I can just make two different vector quantities. Okay. See the diagram very carefully. So basically, what will I do over here? This was your force vector. This was your displacement vector. I'll break this displacement vector into two components. Can you see one component of displacement vector is along the force and one component of displacement vector is perpendicular to the force? Yes, sir. Can you see, guys? This is basically your S parallel and this is basically your S perpendicular. Yes or no? Yes or no, guys? Will this S
Yes, sir.
parallel be equals to S cos theta? And will this S perpendicular will be equals to S sine theta? Everyone knows how to make the components, right? Everyone knows how to make the components, right?
Yes, sir.
So basically, guys, can you unmute everyone? So here, basically, what is the work done by this force? This is basically the force multiplied by what is the displacement in the direction of this force. So basically, can you see over here? Force multiplied by whatever is the displacement in the direction of that force. So basically, this multiplied by this. So F into S parallel, or you can write F into S cos theta. Is this your work? Is this clear, guys? The first case clear? Understood what exactly happened? I told you, it is basically the product of force and the component of displacement which is in the direction of force. So can you see over here in the first case, this S parallel was basically the component of this displacement in the direction of force vector. So multiplied this and this together to got to get the one. Is this clear? In the second case, what will you do? Your displacement vector is as it is. What will we do over here in the second case, Will? What will we do in the second case, guys? What will we do in the second case? We'll resolve F into two components. this is your F parallel, and this is your F perpendicular. F perpendicular is again F sine theta, and F parallel is basically F cos theta. Guys, are you noting this particular thing? Here in both the cases, theta is basically the angle between, what is theta? Theta is basically the angle between force vector and displacement vector. So here also, when we find the work, what will be the multiply? Can you see in the second case, it can be calculated by the product of displacement and the component of force in the direction of displacement. Is this clear? So it's the same thing. It is basically the product of displacement multiplied by the component of force which is in the direction of the displacement. So can you see F parallel and S? Here also it was F and S parallel. Are you getting my point, guys? How is it defined?
Yes, sir.
Okay. So once you do that, you get work done is equals to F parallel multiplied by S. And what was F parallel? It was equals to F cos theta into S. So can you see over here this, this, or this? In both the cases, can you see over here F into S cos theta? F cos theta into S. The work done was equals to F S cos S or no. So from both the definition, we are attaining the same result. Are you getting my point, guys? So basically, this is your work. You can define the work as force can be defined as the final definition you can write can be defined as the product of magnitude of force, displacement, and the cosine of the angle between. Please write this. Am I done? This is clear. Done. Let's write about the quantity. The physical quantity is work. The formula is Fs into cos theta. So guys, will you be able to give me the SI unit? Will you be able to give me SI unit for this? Can you see Newton? Hello?
Yes, sir.
Yes,
Will you be able
sir.
to give me the SI unit? Can you see force is Newton, displacement is meter, and cos theta is nothing, right? So what is the SI unit? It is Newton multiplied
Newton
by
per meter square.
Newton per meter square is Pascal. Newton
Okay.
multiplied by meter is basically work. है ना? And you'll find out this thing is nothing but joule. You remember joule for energy? Newton, meter, and joule, they are one and the same thing. Sir, how, sir? Because since we know, oh, since we know this particular thing, work done is equals to F into S into cos theta. What is work? You see, work is basically a force is basically MLT minus 2. Displacement is L and cos theta has nothing. So can you see the dimensional formula for work is basically ML2T minus 2. If the dimensional formula is this is the same as energy, right? That is why the unit is again the same as energy. Is this clear?
Yes, sir.
The dimensional formula is this. I want to ask you what is this either scalar or vector? So please, it is a scalar quantity. The magnitude of this scalar quantity can be positive, negative, or please remember the magnitude of the work can be positive, negative, or zero. So don't be surprised if work comes negative. Even your electric charge is negative, na? And I have already told you that there are lots of physical quantities which are there which are having negative, right? Lots of scalar quantities which are negative. So whenever you're done writing, done. Is this clear, guys? Done?
Yes, sir.
We wrote something about the work. Please remember, in vector form, if I want to represent this thing, if I want to represent vector form, then do you remember here f and s are getting multiplied? And which kind of vector multiplication gives me a scalar quantity? Everyone knows this is the scalar product, or basically the dot product, right? So whenever it is w is equals to f dot s, you can write it f s. I think we already discussed, when vector, when we did AB cos theta, right? Yes or no?
Yes, sir.
So acha, note, whenever we talk about the displacement of the object, the displacement of the point of application of force. Always remember, whenever we talk about, what is the displacement, we never talk about the displacement of the object. No, 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 not at all. Can you see over here? When we talk, can you see over here? This is the point of application of force. Can you see this is the point of application? So can you see the point of application shifted in the forward direction by a certain distance, right? So can you see over here, guys? Can you see this very clearly? Hello, guys. Can you see this very clearly? This is the point of application of the force, right? And can you see when the object moves, the point of application also moves? Yes or no? So whenever we talk about the point of application, whenever we talk about calculating the work, we talk about the displacement of the point of application of the force. So please note this minute detail. It is not that much relevant, but when we talk about rotational motion, when the object will be a rigid body, then this concept will come in handy. Is this clear? Is this clear, guys?
Yeah.
Okay. So now suppose if I have 3D space, let's say this is x, let's say this is y, let's say this is z, and I have one point, an object at point A, and this is B. If I say the unit vector, oh sorry, not the unit vector, the position vector of A is r1, and the position vector of B is rb vector. Okay, so can you see over here, guys, what is the displacement? What will be the displacement from A to B? What will be the displacement from A to B?
So
The displacement
wait,
from
displacement is,
displacement
sir,
from A to B. Yes.
vector.
Vector. Yes, vector. This will be final position minus initial position. This is displacement, right? ये सबको
Yes,
याद है? ये सब भूल चुके हैं?
yes, sir. No, sir. Remember it.
Initial to displacement vector is basically a vector pointing from initial position to final position, and these will be your initial. Is this clear? RA, RB. Now, suppose if I have a constant force F, for a constant force F vector applied throughout its displacement from A to B. So suppose if I apply a constant force F Can you see this force is acting at certain angle to the displacement? So during the motion from A to B, this force was continuously applied at every point. It was applied in the same direction. Okay. This force vector is the same and it is acting constant everywhere. So basically, what will you do? The work done by this force will be equals to F dot the displacement. Can you see the displacement is basically the RAV vector? Yes or no? You will write F dot RT minus RT. Please remember, whatever we are discussing till now is basically what it is. It is, and whatever we are
Vectors.
discussing, ha, no, no. If the when the force is constant, whatever we are discussing now till now is basically when the force is constant. In the next case, the force will become variable. Okay, I think this is pretty much clear. If many forces are acting on the same point, then the total work done will be basically what? The net force dot RT. Are you getting my point, guys? If more than two forces are acting, or basically more than one forces are acting, then you will do. Please write it. Hello, Sania. Then, guys,
Yes,
Yes,
sir.
sir.
some more points about work, will right? Work is always defined for intervals. The intervals may be big. Guys, please remember, work is never defined for instantaneous. Like, for example, you can define instantaneous velocity, you can define instantaneous acceleration, you can define time also as an instant, right? But you can never define work as an instant. You cannot define work for certain interval of time. This is the work. Oh, sorry. You cannot define work at this. Let's say work at t equals to 2 seconds. Never ever define. You can say that work done by this force between 2 seconds to 5 seconds is this much. You can always define it for interval. Work done from x equals to 2 meter to x equals to 5 meter. So you can define work in these intervals. There is no foundation whether these intervals should be big or these intervals should be very small or anything like that. There is no foundation on the intervals, but please remember, work cannot be calculated on instant. So that is why there is no such thing as instantaneous work. Is this clear? Is this clear?
Yes, sir.
Next thing, it is independent of the type of motion of the object. Sir, what do you mean by this statement? Suppose, let's say this object is initially at rest and I am started applying a force F. Okay. Now, due to this force, what will happen? Due to this force, what will happen? Hello?
Sir, force is created.
Due to this force, an acceleration is created, and this object will get displaced from here to here, right? So here in this case, work done is basically F dot S. Okay, is this clear? Work done will be F into S, right? Here the angle will be 0 because there is nothing over there. So here in this case, guys, can you see the type of motion was what? A straight line motion. If suppose I don't want this force, and let's say the path which I give is basically what, it's a zigzag. So basically the object goes like this. The object goes like this. The object doesn't go in a straight line path, it goes in a zigzag path. But same force F is applied and the displacement is still the same. So here also work done will be F dot S, the same Fs, right? So can you see over here whether the path was straight line or whether the path was zigzag? It was independent of the type of motion, right? So in both the cases, the work was same. Why the work was same? As the displacement was same and the force was also same. Yes or no, guys? So please remember this point very well. It is independent of the time. If the displacement is same, then work will be same. For example, suppose I will give you an example. Uh, One object, another object, 100 Newton force and 100 Newton force, same force. This object is 2 kg. Yeah, 2 kg is too much. This object is 20 kg and this object is 50 kg. So can anyone tell me what is the acceleration produced in both the cases? Yes, guys, can you tell me what is the acceleration produced in both the cases? Hello?
Yes, sir.
What is the acceleration produced in both the cases?
Sir, 100 Newton.
Acceleration
5
produced in
meter per
both the cases.
second.
In this case, the acceleration produced is 100 divided by 20, which is 5 meter per second square. And in this case, this acceleration is 100 divided by 52 meter per second. Cyril, क्या हो गया आजकल इंटरेस्ट नहीं है पढ़ने में?
नहीं सर, पढ़ रहा हूँ. I'm studying.
Calculating the
Sir, wait.
acceleration.
How did you find acceleration?
F is equals to ma. Force was 100, mass was 20. Yes.
Yes, sir.
So with the help of this thing, we found out the acceleration. Now, can you see initially both of them are at zero speed. Final speed will also be different because they will be, enough, guys.
Yes.
Now tell me this particular thing. Can you see in the both the cases if the displacement is same, even if the time is different? Let's say I want to move it how much? U equals to 0 and I want to move it.
How much do you want to move it, sir?
भाई मैं वही देख रहा हूँ ना. Let's move it by 100. So F is equals to half A into B times square and F is equals to half.
Sir, what calculation are you doing?
I'm doing some calculation.
Okay.
80. 80 will be how much?
4 into 10. Yeah.
2 root 10. Right?
Yes,
So
sir.
basically what calculation I was doing, it was like if both the objects were starting at the same time, then this 50 kg will reach at 10 seconds and this object will reach 2 root 20 seconds, which is approximately how much? Which is root 20. So under root of 20 is 4.2 is 8.94. So hey, excellent. Oh, my bad. Everyone, I'm sorry. 5, 20, 100. 22, 40. Under root 40 will be 2 root
2
10.
raised to 10.
टाइम ऐसा कैसे आ रहा है? What is this possible?
Sir, wait. I'm understanding nothing right now.
अरे 2 मिनट भाई, मैंने समझाना चालू नहीं किया अभी. I'm just calculating some.
Okay.
And so guys, these calculations, they don't matter.
Got it, sir?
Yeah,
Got it?
yeah, got it.
Okay.
So now see this thing very carefully, guys. In the first case and the second case, what is the only difference? The difference is basically the acceleration in the first case and the acceleration in the second case is different. The force which is acting on the block is 100 Newton and the force which is acting on the block is 100 Newton. This block was 20 kg and this block was 50 kg, due to which what was happening, the acceleration produced was different. The acceleration of the first block was 5 meter per second square and the acceleration of the second block was 2 meter per second square. What do you mean by the acceleration being different? The acceleration being different means that this initial block, the first block is moving faster and the second block is moving slower. So when we calculated the time for, let's say, 100-meter distance, so this block was reaching it after 10 seconds and this block was reaching after 6.32 seconds. Okay, so can you see over here, irrespective of the time, can you see both the objects are reaching at a different time? But can you see the forces is same, the displacement is same. So in both these cases, the work will be same. This is what I was trying to prove. Now you understood what exactly I wanted to do. The data doesn't matter. Can you see over here? This was 100 Newton moving faster. Oh, sorry. This was 20 kg which was moving faster. This was 50 kg which was moving slower. Hence, the slower object will take more time to reach. The lighter object will take lesser time to reach. And can you see in both of the cases that the displacement is same, then the work done by the force in both of the cases will be same. So can you see over here it is independent of the time. When the force is same, displacement is same, so whatever be the time, doesn't matter. The work done will be same. Is this clear?
No,
Now,
sir.
got my
Can you
point now?
explain it once again?
Once more.
Sir, I didn't get the point. Please explain once again.
Yeah, sure. Then, can you see force acting on both the objects? What is the force acting on both the objects?
100 Newton,
What is the displacement by both the objects?
100 meters.
Since the acceleration of both the objects was different, can you see? The acceleration of the first object was 5 meter per second square, and the acceleration of the second object was 2 meter per second square. Since the acceleration is different, hence the time taken will be different, right? To cover 100 meters.
Yes.
Right? So basically, can you see over here, the faster moving block is taking lesser time and the slower block is taking more time. But in both the cases, it is traveling how much distance? 100 meter only.
Yes,
Both the
sir.
objects were traveling 100 meters. So can you see over here, the force acting on both the objects was same. The displacement of both the objects are same. Even though the time was different, still the work done by these two forces will be the same. So can you see work done is independent of the time. If displacement
So
is
wait, what
same,
is the work again, sir?
work will be equals to, the work done in both the cases will be equals to 100 Newton multiplied by 100 meter, which is basically 10 to the power 4 joule. In both the cases, this 100 multiplied by this 100, this per case. This is the work done in both the cases. Okay. Hello.
Yes, sir. So wait, what's the definition of work again, sir?
Which is basically the product of force multiplied by the displacement in the direction of force.
Oh, okay.
The force multiplied by the displacement in the direction of force. We just multiplied. Is this clear?
Sir, but wait, in the above statement, sometimes the force will be different, right?
Yeah, sometimes the force will be different, but it won't be the same force, no? Whenever we
Sir,
talk
meaning?
about, whenever we define work, we define it for a force, right?
Yeah.
So if you change the force, automatically work will be different, no? Can you see? For the same
But sir, you
force,
haven't mentioned. But sir, you
for,
haven't mentioned force in the point, right?
but beta, like एक बात बताना, whenever you are comparing between work, at least one point should be same, no? So we are comparing the work done by this 100 Newton in two different cases. What were we comparing? The work
No,
done
sir, like
by,
you only mentioned displacement, right? So like displacement will be same, then work will be same.
but मैं वही बोल रहा हूँ ना, we are comparing for a single force, no? That is this 100 Newton force. 100 Newton force
Oh, okay.
doing work in two different cases. So
But
100
with same
Newton force,
force.
same force was doing, two different. Can you see? The same force was doing two same work done when the
So the whole topic contains same force.
अभी तो नहीं. In this point, it contains the same force. Okay? There will be
But sir,
different
it's not
forces.
mentioned, right? In your point, same
अरे
force.
मेरे भाई, इसको कोई समझाओ यार, please. Anyone? Please
Sir,
try
only
to
you can
explain.
make me understand, sir.
नहीं, I telling. मैं इसको तो क्या बोल रहा हूँ देखो. It is what, it's the same force, 100 Newton. Just suppose कर ये वाला case है नहीं. Suppose that this case doesn't exist. But, this case is not there. Okay. So can you see in this case, this force was acting on this 20 kg block, then 100 meter. Okay. Hello.
Yes, sir.
So what was the work done in the first case? What was the work done in the
Case,
first case?
it was 100 joules.
It was 100 joules. Now basically what did you do? You applied this 100 Newton force. You applied this 100 Newton force on where? on 50 kg block.
Yes, sir.
So now you say, in this case, if the same for the same displacement, what is the work? 10 to the
The
power 4
same
joules.
displacement.
Can you
Yes,
see
sir.
this? So can you see this particular thing when the same force is applied for the same displacement? So basically we are comparing between two cases when the same force was applied. अब समझ में आया कि नहीं आया?
But sir, no, what I didn't understand is why didn't you mention same force in your point?
बेटा तो
It
मेरे को
is
एक बात
independent.
बता, if I'll change the force, automatically the work done will become different, no, for the same displacement.
Of course,
So
obviously.
फिर if I want to compare between two cases, at least I need to put something constant, no? You remember uniform motion, non-uniform motion definition? You said no
Like,
when
sir, you already mentioned displacement to be constant, right?
हाँ for the same displacement. If displacement is अरे यार ठीक ले मैं लिख देता हूँ ना uh, for the same force in two cases, if the displacement is same then the work is same. Is this clear?
Yes, sir.
अच्छा पहले अभी रुक जा
That makes sense.
हाँ ठीक where is this control? Why is it not happening? Control that. That is gone now. I think you people might have written it over here somewhere. And for a same force in
Sir,
ठीक है
wait,
भाई सूरज
diagram किधर है? 20 kg वाला.
yeah I need to draw it again no because to make you understand अब क्या करूँ please note it down. So, once you're done with this, we'll discuss the types of work, the positive, negative, and zero work. Yes, guys, are you done noting down?
Sir, लिख रहा हूँ. I'm
Please
still
write.
writing.
Yeah, sure. Please write. Done.
Done, sir.
Okay. Cyril, are you done?
Of course.
Heading डालें. Types of work. Now, what are the types of work? See, basically, work can be classified into three different types. The first one is basically positive work. The second one is negative work, and the third one is zero work. So let's discuss them one by one. We all know that work is basically equals to Fs cos theta. Here, this F is magnitude, S is magnitude, and cos theta is basically the angle. Right? Yes or no, guys? Hello, guys. Everyone knows this particular thing, no? Okay, why there are why are there three different types? F, S, and cos theta. This is magnitude. Both are magnitudes of something, so always positive. Whereas this cos theta term, this can be positive as well, this can be negative as well, and this can be zero as well, depending upon the angle, right? So everything depends on this angle, positive, negative, and zero. So when do we say, well, when the work done is positive? When do we say the work done is positive? When theta lies between 90 degree and 0 degree. 90 degree not included. Can you say 90 degree is not included over here?
Yes,
When
sir.
theta lies between, we say, the work done by the forces. Please remember. Special case is basically when theta is 0 degree. When theta is 0, then can you see over here, you'll write work done is equals to F into S into cos 0. What is cos 0 degree? 1, right? Cos 0 is
Yes.
plus 1.
Yes.
So basically here the work done will be F multiplied by S, but please remember this work will be the maximum possible work. Why? Because cos theta has the maximum value of plus 1. Okay? So here the work done will be maximum by a force. Please write it.
Sir, what is S?
Displacement.
Okay. Sir, done writing.
Now the next case will be what? Achha, can anyone give me example of positive work?
Sir, a small doubt, sir. Can you just scroll up?
Where?
No, sir, just right there.
Here?
What is? No, sir, a little bit more down. Right there, sir, right there. Please stop moving it. What is this, sir?
This is, see, why is there three different types of work? It's all because of this cos theta.
Yes, sir.
F and S both are magnitudes, so they will be always positive, right?
Yes, sir.
But this cos theta can be positive, negative, as well as zero, due to which the whole work will be positive, negative, and zero, and that is how we categorize our work. So on the basis of this angle, we are categorizing this work. Okay.
Sorry, sir. Can you explain once again? Because I mean, like, if theta is between 0 to 90, won't it always be positive?
Yes, that's why then there will be positive work but when theta will be negative in second quadrant, when theta will be between
Oh,
90
okay,
and
I got
180.
it.
Are you getting my point?
Oh, so we are talking about three cases now. Okay, I
Three
see.
cases now. Yes, we're talking about three cases. The first case is positive work.
Sir, wait, why can't this one theta be like between 0 to 180 or something? Why is there like limit till 90?
Because 90 पे it will become zero. Cos 90 is zero, no?
Yes.
So this is the case.
So
Whatever
from 90
case,
onwards, what will happen, sir?
the work done will become negative.
Okay.
First, this is clear. I guess this is pretty much clear. Positive work. The next is basically negative work. यहाँ से the cases becomes a little bit interesting. So when will the work done be negative? Work done by a force will be said to be negative when the angle between the force and the this thing. When the angle between the force and the displacement vector will be between 90 degree and 180 degree. Again,
So
90
sir,
degree.
after 180 degree, it will be zero work.
After 180 degree, it will go in the second quadrant, but we'll limit our angle to 180 degree. We
Yes,
need
sir.
to limit our angle to 180 degree. We will not go beyond 180. For example, suppose if this is the case, then you will have this as the angle. If this is the case, then you will have this as the angle. And if suppose this becomes the case, if this becomes the case, then you will not take this as your angle. Okay? You will take this
Yes,
as
sir.
your angle. Are you getting my point?
Yes, sir.
So basically, you need to limit your theta to between 0 and 180 degree. Then I'll write this as well. Note, please limit the angle between 0 and 180. Don't make it greater than 180. Okay? Is this clear,
Yes,
guys?
sir.
Now,
Yes, sir.
Yes, sir.
so when this angle is, when theta is between 90 degree and 180 degree, then we say work done is negative. Special case will be when theta is 180 degree. When theta is 180 degree, work done will be in F into S into cos 180. And please remember, cos 180 is basically minus 1. So work done will be, in this case, will become minus of Fs, and that will be the minimum possible work which a force can do. Okay? Is this clear, guys?
Yes, sir.
Can anyone give me an example? For example, suppose I'm giving you a question only. An object initially at rest is placed on a rough horizontal floor. An object of mass, दे देता हूँ मैं, mass 10 kg. An object of mass 10 kg initially at rest is placed on a horizontal floor. If force, horizontal force of 100 Newton is applied on the object, find the work done by the 100 Newton force. Second, work done by frictional force. Chalo, find it out, please. Fast. This is your question. I have not drawn the pictorial representation of this question because that is what you people need to learn. So this is a statement given to you. Draw the diagram on your own and draw the, and try to solve the question. Who will tell me what will you do in this question? Does anyone know what to do in this question? The only thing which you have learned till so far is basically what? We did a whole chapter on it. From the past 1 month we are doing it. Tell me what is it? This is a 10 kg block initially at rest, placed on a rough horizontal floor with mu equals to how much? 0.2. Now we'll come back to the displacement later on everything. First let's calculate what is the value of limiting friction. Will it be equals to 0.2 multiplied by n, the normal reaction? Yes or no? But do you know this thing, normal reaction and Mg will be equal in this case as this block is not flying or anything. So in this case, what will be the case over here? Mg will be, as Mg will be, let take G as 10 meter per second square. So the limiting friction will be 0.2 into 10 into that is 20 Newton. This is the limiting friction. And now what is the force which is acting on this thing over here? 100 Newton. Now due to this force, this object will try to accelerate, but friction will oppose this. And what will be the friction? Since can you see over here, 100 Newton is way bigger than 20 Newton, then this block will be sliding and it will be accelerating towards the left. What will be the acceleration of the block? Will it be friction or the driving force minus the frictional force divided by the mass? So this will be 100 minus F is 20 Newton. So this will be 8 meter per second. So now the acceleration of the block is known to us. The initial velocity is known to us. We need to find the displacement so that we can find work. And what have they asked? Oh, I'm not given time. So let's give both the case in time. Guys, थोड़ा सा change कर लो. For 2 no, 2 seconds less for 10. Can you see guys over here? I just modified the little bit question because time variable was required. So force of 100 Newton is applied on the object for 10 seconds. Then find the work done by this 100 Newton force during that interval and frictional energy. So displacement you want to calculate and they have given time as 10. Now I think you can find out S very easily, right? S is equals to U T plus half A T square. So will the displacement be 400 meters? Yes or no? Now we know the displacement, we know the force. What is the work done by 100 Newton? Will it be equals to force S into cos theta? So the force is basically 100. S is basically 400. And can you see the direction of this and the direction of displacement is one and the same. So hence cos theta. Positive work, how much? Joule. Work done by friction will be equals to small f into S into cos. So now friction will be equals to what? What was friction? Friction was 20 Newton. The displacement was 400. Guys, see very carefully. What is the direction of friction? Friction is acting towards left, but the displacement of the object was towards right. So hence cos 180, due to which this thing will become negative. Are you getting my point? So minus 8,000 joules. This is the work done by. Can you see it is negative? This is your answer, and this is your. Here, please write it. please remember this thing, guys. Once you are done with this, please, we'll come back to positive and negative work. Please remember, whenever work done is positive, that implies the external force is supporting the motion. Okay? Whenever the work done is positive, that implies the external force is supporting the motion. And whenever the work done will be negative, that implies the external force is
Against the thingy. Sorry, what
against
are
the
we doing?
motion.
Oh yeah, against the motion.
Is clear?
Definitely
Don't
not lose motion. Proper motion.
भाई मत मारे कर फटे हुए. It's okay.
Just kidding, sir.
You
Sir, मैंने आंसर लिख लिया.
guys, everyone copied this thing.
Yes, sir.
Of course.
Now let's talk about the last type of work, which is basically what?
Zero work. Where work is not done. That is at 90 degree. Right?
Now the third case is basically what?
Theta equals 90.
Now zero work.
Theta
Zero
equals
work.
90.
Arre,
What?
minute Shanti.
Yes, sir.
क्या हुआ? अरे मैं कहाँ तक हूँ यार खत्म.
मैं दे रही हूँ बस. कैसे लगे?
अच्छा लगा.
ये लेके जाएगा?
हाँ अच्छा लगा. ये तल के दे देना, पैक कर देना, मैं कल तल के खा लेगा वहाँ पर.
हाँ. मजे की पिक कर दो.
ठीक है.
Sir, what are the three types of zero work?
वो बता रहा हूँ ना तुम्हें. So work done is F S cos theta. Yes or no? And now,
Yeah.
if you want this thing to be zero, it's not necessary only this thing has to be zero. Can you see? Even this can be zero, this can be zero, right?
Yeah.
So basically, there are three cases of zero work. Case one,
No force.
when force is zero. If there is no force, then
No movement. No movement, no
no,
work.
no. ऐसा नहीं है. Movement will be there, but then whose work are we defining? Are you getting my point?
Sir, if you don't apply the force, then what is moving? Without movement,
It
what
moves
work
with a
is there?
constant velocity, no?
What?
It moves
Sir,
with a
how
constant.
can there be movement without force? Like, you need
It's
to
supposed-
apply some force to make something move, right?
No, it's not necessary. If you move with a constant velocity, automatically what happens? Suppose this is going at 10 meter per second. So it will keep on going with 10 meter per second until unless an external force is applied, right? So see, the
Oh,
movement
yeah.
is there, but when it is the uniform motion, if you remember uniform motion, external force is zero, right?
Yes, sir.
So here if there is no force, then whose work are we defining, right? Yes or no?
Yes,
So here
sir.
no
Yes.
work is done by any force. Is this clear? Case 2 is very interesting. When the displacement is zero. Suppose,
Sir, where will you move the object actually?
huh?
If displacement is zero, where can you move the object? Because
Ah.
like your initial position and last position is same.
Exactly. Suppose this is a wall which is fixed to the ground, and this is you, this is Cyril, and the Cyril is basically trying to
Push a ball. Sorry, throw a ball. Kick a ball on the wall.
Cyril is trying to push
Sir,
the
मैं
wall.
football खेल रहा हूँ.
No.
What?
You are trying to push the wall. Will the wall be displaced from its position?
No.
So basically in this case the displacement is zero. So even if you are applying the force, even on applying the force,
Sir, just a small question, sir. Why is the shortest distance called displacement?
I don't know. मतलब इसको नाम दिया है तो दिया है?
Simply they gave it for no reason.
I don't know. I never checked into what's the reason for naming it displacement. Do you know any reason?
That's why I'm asking you, sir, so I can learn some reason.
नहीं ऐसा कोई reason नहीं है ऐसा तो why did you were named Cyril?
Sir, my parents named me Cyril.
Bas exactly the one who
But this one
discovered.
does not have parents, sir.
Who said?
This one does not have parents.
ऐसा there is nothing which was not invented by anything which you are not
Sir,
saying.
the name has no logic, basically.
Does your name has any
Without any
logic?
Sir, it's human name, sir. This is
So
this
exactly
one.
when we were discovering a concept of suppose
Yeah.
there is something called as quantum tunneling. A tunneling we
Yes.
understand it's a tunnel like structure being formed. What do you mean by quantum? Who gave this word
Quantum
quantum?
means very small. Some guy named Quantum, I guess.
नहीं भाई मैं बोल रहा हूँ ना quantum. Who said quantum is very small? Some guy mentioned this thing, basically we can't go
I think
and
his
question
surname
the
was
dictionary
Quantum
and
or
all.
something, sir.
Huh?
I think his surname was Quantum.
ना ऐसा कुछ नहीं मेरा भाई quantum नाम का कोई बंदा नहीं है.
Or
Anyways,
maybe in Latin, quantum means very small.
maybe
Latin,
तो
Greek.
वही मैं बोल रहा हूँ ना basically what happened कि the guy who made the dictionary for various languages, you need to go to them and ask why it is named as this place.
Sir, I'm sorry for asking the question, sir. Can
अरे
you please
नहीं
continue?
उसका जवाब मेरे पास नहीं है.
Sir, my question is not getting answered, so it's fine. It doesn't matter, sir. Can you continue the topic?
Guys, is there anyone who can answer his question, please?
Sir, I'm very happy, sir. Please continue the topic. Please, I beg you, sir.
नहीं मैं पूछ लेता हूँ कि if I am not able to answer your question, then is there anyone else who would like to do the honors? कैसा question है यार? कुछ भी. This question has
Sir,
nothing
I just asked
related
out
with
of
physics.
curiosity.
अरे नहीं
Just-
पता.
what?
I don't know. I don't know why it is called as displacement. Is called as displacement.
Okay, no worries, sir. I found the answer. It is fine.
So what is the answer? Tell me.
Sir, the answer is you don't know why. That is the answer, right?
No, that so I know, but do you know the answer for the question?
Sir, you told me the answer, right? You don't know. So, yeah, okay, good. Nice answer.
Janate, avoid. So even on applying the
Thank you,
force,
sir.
the object can't move. That is why the displacement is 0, and that's why work done by force is 0. Similarly, suppose if there is a heavy object, there is
Yes.
a huge object, and let's say mass is
That
F.
cannot be moved with
That
human
cannot
force.
be. Suppose if we are applying a force F and it is placed on a rough horizontal floor with mu
So
like
its
this,
mass is like 500 kg or something.
something like that. So suppose again Cyril is there. Okay. So there will be
Yes.
friction acting on this thing. Let's say the force applied by him is 100 Newton, and the friction, the value of limiting friction is how much? 500. Oh, sorry, I didn't give any mu. Let's give the mu as 0.2. So 0.2 multiplied by 500 into g, basically 10. So the limiting friction value is 1000 Newton. So can you see the limiting friction is 1000 Newton? You are applying 100 Newton. So what will be the friction in this case? What will be the friction acting on this block? Will it be 1000 Newton or will it be something different?
Like minus 1000, I guess.
No. Will it be minus? Guys, can anyone tell me what will be the frictional force over here? External
It will be
force.
100 Newton.
External force is 100 Newton.
So minus 100. Minus 100.
Minus 100. Direction we drew. We drew the direction towards the left.
That's what? Vector F is basically minus 100, right?
But abhi we don't want. I drew the direction. I just want the magnitude. What will be the force?
Oh, okay, 100.
Magnitude of it.
Then 100, sir.
So now can you see when the two forces are acting, these two forces are acting on this block and the forces are balanced. So even if there are multiple forces and the forces are balanced, still the object is not displaced. So here also displacement is zero. Acha, अरे guys, this question, this part can go over in the first case as well. है ना?
Meaning,
If there is no force, then work, whose work we are defining? Or if two or more forces are acting, but the net force becomes zero. If the net force becomes zero, then again the total work done will be. Is this clear? So this goes in the first case as well. Here the displacement is not zero because you are not able to displace it. But here the forces are also zero, so even it can be zero work according
so
to
wait, sir.
whatever.
In case one, it doesn't matter if force is applied or not. It has to this one final force has to be zero.
The net force has to be zero. If you apply a certain force, but you apply certain force in such a way that the net force becomes zero, then also it will be case one, zero work by net force. Okay.
Okay.
So please write it. Please write it. Write it. Draw
Sir,
it.
लिख लिया.
Whatever you want. It's up to you.
Sir, done, son. The done.
Done.
Done. Yes.
Now the third, guys, case three. What is the last case? When cos theta is zero, and when cos theta will be zero, then theta will be.
90.
So always remember when the angle between force vector and displacement vector is 90 degree, then the work done by the.
Sir, wait. In vectors, where is work exactly?
What?
Sir, can you show on a graph?
क्या भाई क्या चाहिए देखो?
Sir, the work vector.
Work is not a vector. Work is a scalar
Then
quantity.
what?
Work is a scalar quantity. We wrote it already.
Oh yeah, of course.
Sorry. Yeah. Scalar quantity can be positive, negative, or zero. So guys, do one thing. Write down some examples of this thing. I'll be just back into it. खुद से लिखो अपने मन से. Then I'll make you write some more examples on this. Last case is very important.
Done writing, sir.
Are you done writing the case 3 examples?
Yes.
Case 3
Sir,
examples.
only one example. Wait,
Case 3
examples?
examples.
Sir, you hadn't given.
हाँ, so
You
that is
hadn't
what.
given them yet.
Think and write. सब चीजें मैं नहीं करूँगा. वही बोल रहा हूँ.
Oh,
Write
we
down
have
at
to
least
write.
two examples. Then I'll give you some more. I'm coming in 2 minutes. है ना?
Oh, sure, sir.
हाँ, चलिए फटाफट. Write down 2 examples in that time. Hello guys. Yes. Can anyone tell me what examples did they write? Yes.
Sir, I didn't understand case 3. Can you please explain it once again?
Wow, very good. That's the best example for not doing anything. The See, the last case was when the angle between the force is basically 90 degree. Then the when you write cos 90 over there, so cos 90 becomes zero, right? So that's why the force automatically does zero work over it, because the work when you write theta as 90 degree in that particular thing, the formula for work, then automatically Fs cos 90 becomes zero. So work becomes zero. Is this clear? Example के रूप में, suppose there is an object and let's say this object is moving with 5 meter per second in this direction, and it still moves with 5 meter per second. This is a frictionless surface, so smooth. Now can you see over there, guys, this object has displaced, let's say, by 10 meters. Okay, what all
Sir, wait.
forces?
How is it? How is there constant speed?
Because I have given it a constant speed. Initially it was moving with a constant speed, it moves with a constant speed. I have not applied any force in this direction. Can you see any force?
But sir, what about friction?
Or bolo, it's a smooth surface, hence no friction, right?
Sir,
No
but you previously also said that smooth surface will also have this one, some or the other bumps.
but abhi I'm assuming friction is zero over here. Exact zero, nothing, no change.
Or
Not
how
even
can you assume friction to be zero when it's a smooth surface? And he said like there will be a lot of friction in this case.
Nah, beta,
Something
that
like
is
that, right?
when lot of friction happens when this is smooth and this is also smooth. Perfectly smooth. When these two surfaces they have relative motion between each other, then friction becomes infinite over there. यहाँ
Oh.
पे नहीं है. यहाँ पे one surface है, this surface is smooth on which this block is placed. So anyway, F is zero, F is smooth, and what all forces are acting over here? Can you see on this block there will be mg acting in this direction and normal reaction acting in this direction? Yes or no? So can you see over here the
Yeah.
displacement over here in this case? Normal reaction is like this. Displacement is like this. What is the angle between these two? Yes, tell me what is the angle between these two? 90 degree, na? Yes or no? Can you see the displacement was towards right, normal reaction was acting towards upwards? Hello?
Yes, sir.
Can you see? Zero work again.
Yes. Yes.
One more example I'll give.
Yes. Sir, what did you write? Pets.
Right.
Whenever a pets.
Porter. Coolie. India में होता है ना coolie.
Sir, who is a coolie?
The guy who carries your luggage on railway stations and all.
Oh, okay.
So whenever this porter carries a luggage on his head, the work done by him is zero. Hannah, please remember we are talking about the work with physics, which is defined by physics, and not, saying the work, defined by what we define, right?
Sir, poor guy is not going to get money, sir, if you tell
हाँ,
this to him.
नहीं, तो he'll beat you.
वैसे नहीं कमाएगा.
He'll beat you.
वो
That's why.
वो मारेगा नहीं, उसको पैसे नहीं मिलेगा,
Yeah, exactly.
कुछ भी काम नहीं करता है.
So now
Poor guy
suppose,
works hard, carries all luggage, ends up not getting money.
guys, suppose, hello. Okay. So basically, this guy is walking with you. So suppose this is you, and this is the porter. Both are walking in the forward direction. है ना? So even he is walking here, and you are walking. Now, see, guys, very interesting. What is this guy working against? Can you see why are you not able to carry the bag? Because it was too heavy, right? Yes or no? So the
Yeah.
bag's mg was acting downwards, and basically this guy was applying a normal reaction on this bag in the upward direction, है ना? And that is why the
Yes.
normal reaction and mg is basically equal. So what are you paying him for? You are paying him for applying this force. Okay?
Oh.
Paying him for. Please remember, the work done is different. Can you see in this case, the displacement? Can you see the object is going towards both the object? The bag is going towards right. Yes or no?
Force and displacement are perpendicular.
Here, displacement is towards right. Right. The normal reaction is acting upwards. So can you see, normal reaction is upwards, the displacement is towards right. So technically speaking, the work done by normal reaction is
0.
done by normal reaction is, technically speaking, work done is 0. But please remember, the work which we do in physics and the work which he is doing is different. He earns money by that work. We don't earn any money by that work. Huh?
Sir, I have another example.
Please give it.
Sir, farmer is this one. What do you say? Hoeing. How do you say it again? Sir, farmer is taking hoe and he's plowing his field. Yeah.
So,
He's applying force downwards and then he's pulling it towards himself.
so basically it's not like that. When the farmer is plowing, it's like this, suppose, है ना? And then he pulls this thing in this direction. To pull this thing in this direction, basically what he's doing, he is pulling it with this force, right? Yes or no?
Oh. Yes.
So now when he's pulling it with this force, you can see even the plow, this whole thing is moving in this direction, right? Although there is
Yes.
friction, from the ground, but still this fluff is moving in this direction. What do you call this thing? Guys, does anyone have any idea what is this thing called? Yes, sir.
Oh. Pickaxe.
Like pickaxe is not this. Anyways, whatever is this, so basically this force will do a positive work and this force will do a negative work. There's no zero work over here. Okay? The mg does a zero work. The normal reaction does a zero work. Yes or no?
Sir, another this one very good example I have. Sir, you watched Bahubali?
Yeah.
Okay, when he was carrying Shivalingam.
So it's basically this only, no?
Yeah, that's what I'm trying to say, sir.
So this is basically the same thing. Anyways, guys, 2 more examples. Please write as your homework. Okay?
Okay.
So we are done with work, positive work, negative work. We are done. only the work done by a variable force is left. So in the next class, we'll do work done by a variable force, some questions, and we'll finish off with the work. We'll start with energy. Now the chapters are going to be very small. They're not big chapters at all. Then now the next big chapter will be in rotational motion. Okay.
Okay.
Before that, the work per energy, the conservation of momentum, center of mass, they will be small chapters, very small chapters, just like circular motion, friction. How are they in parts, right? So just like that, we will be done with those very soon. Check. Anyways, thank you very much. Yes, we'll see you.